Hello everyone, class 12th. Topic is dipole moment of ortho, meta and para dichlorobenzene. Three molecules. This is ortho dichlorobenzene, ortho. This is meta dichlorobenzene and this is para dichlorobenzene. How to find their dipole moments? Let's check. Before finding dipole moments of these cases, first we need to understand this topic. Vector. In physics, it is available vector quantities, scalar quantities. So what are vector quantities? Which have magnitude as well as direction. For example, displacement and dipole moment, the topic which we are dealing. So the quantities which have magnitude means the value is there as well as the direction. They are vector quantities. Dipole moment is also a vector quantity. Let's check how. Suppose A and B, two atoms are there connected with each other through a covalent bond. Suppose B is more electronegative than A. So these electrons are little more toward B. So B is carrying negative charge, A will carry respectively positive charge. So now this molecule is working as a dipole. And if we have a dipole moment is also available there. The direction of dipole moment always from negative to positive. This direction from negative to positive. And obviously it will have some value which will be calculated by the formula. Dipole moment can be calculated through formula charge multiplied by distance between atom. Already we have done this. So in this fashion, dipole moment will have value means magnitude as well as direction from negative to positive. That's why dipole moment is vector quantity. Now, in these cases, I will take example of ortho. Chlorine is more electronegative than carbon, so electrons are going toward chlorine. Chlorine is carrying negative charge, carbon will carry a positive charge. A dipole is generated there. If dipole is there, dipole moment will be there. The dipole moment of this dipole, already it is calculated 1.69 D. D is the Debye unit of dipole moment. Similarly here, chlorine is more electronegative than the carbon, so electrons are going toward chlorine. Chlorine is negative, carbon is positive. This is a second dipole whose dipole moment is again 1.69 D. Now, when we have two dipoles, suppose this is first dipole and this is second dipole, and their originating point is same. Like if I increase this dipole up to here and this dipole up to here, their originating point will be same, this one. Now because we know dipole moment is a vector quantity, so when two vectors are starting from a same point, their addition is given by a law that we call parallelogram law. For the addition of two vectors which are starting from same point. According to this law, the formula is for such kind of vector addition, suppose this is vector A, this is the vector P, this is vector Q. So resultant addition of these vectors will be given by this formula. P square Q square plus 2PQ cos theta. P means the value of this vector, Q the value of this vector, multiplication theta. Theta is the angle between these two vectors. This one. So this is the formula by which you can add two vectors which have certain angle between them and they are starting from a same point. Because dipole moment also a vector quantity, so same formula we will apply for their addition. Now let's check angle first. If I talk about ortho case, this carbon is sp2 hybridized. So between this bond and this bond, angle will be 120 degree. But we don't want this angle. We want angle between these two chlorines. This one. So what will be the angle between these two chlorine? Look, it is very easy to judge. Just draw a parallel chlorine over here to this one, like this. In this fashion, you can find out the angle between them. If overall it is 120 degree, don't you think it will be a 60 degree? Check. In this fashion, you can find out angle between these two chlorines. Similarly, you can find out angle between metacases. What to do? Just this chlorine is written here to make it here. And up to here you can join. So what is the angle? We know what is the hybridization of this carbon, sp2, and in sp2 orbitals the angle between bonds is 120 degree. So in meta cases, this chlorine and this chlorine will have what angle? 120 degree. And in para cases, between both chlorine, what angle we have? Clearly visible, the angle will be 180 degree. Please check carefully how to check angle between two chlorine atoms in dichlorobenzene cases. This was ortho. This full angle is 120 degree. So to check between this chlorine and this chlorine angle, you just pick this chlorine and draw it here as it is. And you will find it will be half of 120 degree. So angle is 60 degree. Same here. Here we have chlorine, just pick it and draw it here and check. It is sp2 hybridized, so obviously the angle will be 120 degree. So in meta case, between two chlorine atom, 120 degree. In ortho case, between two chlorine atom, 60 degree. And here, 180 degree. Cos 60 degree is 0.5. Cos 120 degree is minus 0.5. And cos 180 degree value is minus 1. Now let's put these values in parallelogram law formula. For example, for an ortho case, this is first dipole, this is second dipole. The dipole moment of this dipole is 1.69 d. The dipole moment of second dipole is also 1.69 d. So let's apply it vector addition, because this is a vector, this is also a vector. So to find overall dipole moment, we have to add them. We will not add it just like a simple math, 2 plus 2. No, we will apply a law, parallelogram law, which is saying how to add them. Suppose this is P, this is Q. So what is the formula? P square Q square plus 2PQ cos theta. So P square, suppose this is P, so 1.69 square plus Q, suppose this is Q, 1.69 square, 2 multiplied by 1.69 multiplied by 1.69 and cos theta. Cos theta will be, in ortho cases, what is the angle between chlorine? 60 degree. So let's solve this. 1.69 square plus 1.69 square, 2 multiplied by 1.69 multiplied by 1.69, and cos 60 degree value we know it is 0.5. So in front of you I am going to solve it. .69 square multiplied by 1.69, so 2.8561 is the value. Keep on writing it. Here I will write 2.851. This case have value 2.851. Similarly, this will also have value 851. 2 as it is. 1.69 multiplied by 1.69 is giving us 2.851 value, and 0.5 cos 60 degree is giving 0.5 value. Let's solve it. 2.85161 plus 2.8561, 5.7122 value, 5.7122 plus, let's solve this part. 2 multiplied by 2.851 multiplied by 0.5 is giving us value 2.851. 2.851. Let's add it. 2.851 plus 5.7122. The value is 8.5632. Root 8.5632. Let's find out the under root value of 2.5632 directly from Google. Under root value 8.5632. The value that we are getting, it is around 2.9262. So approx value we are writing 2.926, this one. So this is the dipole moment value of ortho dichlorobenzene case. Because dipole moments are vector quantity, so this is the first vector, this is the second vector. Obviously, to find dipole moment of overall molecule, we have to add their dipole moments. Because they are vector, so we can't directly add them. We have to apply parallelogram law. And be careful when to apply parallelogram law when the two vectors are originating from a same point, which they are. This is first dipole moment, second dipole moment have a same origin point. So in this condition, you can apply parallelogram law for vector addition. The law is saying this. This is the formula to add vectors according to parallelogram law. Suppose this is first dipole moment, which I am calling P, Q, and 2PQ cos theta. So just put the values we know. In previous videos, I have told you the value of these dipole moments, carbon and chlorine, 1.69D. Just keep on putting these values in the formula, and finally you will find out 2.926 is the dipole moment of this case. Similarly, you can find the dipole moment of meta as well as para. When you will solve para case, you will find out the value will be 0. The dipole moment value will be 0 there. And please be careful while finding theta, because mostly students think that it is sp2. The angle is 120 degree. The student used to think that between this chlorine and this chlorine, the angle is 120 degree. No. How to judge this angle? If you will join them here, you will find out this angle will be 60 degree. A technique I told you how to check it. Just pick this chlorine, this bond, and as it is, draw it here. Means this and this, they should be parallel. And then check this angle. This angle. This angle will be 60 degree. Half of 120 degree. Same for meta. Suppose here we have chlorine. So take this chlorine from here and draw it here, parallel to it. And now check angle between this chlorine and this chlorine. Exactly it will be 120 degree. In this fashion you will find out theta. That's it. This is the end of the video. In this fashion we will calculate dipole moment of ortho, para and meta dichlorobenzenes, in which para will get 0 value. Check by yourself. Thank you very much.